Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we already started discussion on Kafka Connect and we discussed in detail about the Snowflake sync connector, right? Where basically that particular connector consumes the data from a particular topic in Kafka and then write that data in a Snowflake destination table. If you want to know that detailed explanations, you can go through the link given in the description box. So this particular pattern is a very common pattern in real-time data processing. That is, for Kafka-based message queue system, the target is a classical relational database or data warehousing system. That is a very common thing. Okay. Now, consuming the data from a particular topic and using it to update a database table sounds very straightforward. But there are few challenges around reliability component in this particular scenario where we are writing the data in a particular database table after consuming it from a topic. What are those? Let us try to understand first, and then we will see what are the points we need to keep in our mind when we will create a database sync connector, or what are the things which goes on in the backend. Okay, right? So for example, let us suppose that we want to build an application that maintain account balance. Okay, so there is a front-end system which acts as Kafka producer and it publishes the events or transactions in a particular topic when a consumer deposit money or withdraw money from his or her account. Okay, so here is our producer, which is front-end system, which is publishing the data within a Kafka topic. That topic might have multiple partitions. There within multiple segments the data are getting written. Okay, and in the consumer side there is a consumer which read the data, that is those transaction, it read whatever amount is deposited or withdrawn for that particular account. It will read from this topic and then it will update the total account balance in the account table in a particular database. Okay, so when the amount is deposited, then the amount for that particular account will increase, or if the amount is withdrawn, then it will be deducted and the deducted amount will be reflected in this account balance table. Okay, right? That's the simple architecture. Now the crucial part in this kind of very important financial system is that we need to ensure the consumer is consuming each transaction only once. It is not like it is processing that same transaction multiple times. And simultaneously, one more thing we need to take care of very seriously, that is not a single message should be missed. Okay, suppose you deposited some amount, that information came to topic, but the consumer somehow missed that particular event to process. So in your actual amount, the deposited amount will not be added, right? And that will be a very big mistake in our financial domain, right? So I hope you understood the crucial part of this architecture, and that is the design will be making sure that every message in the queue leads to only one update of the balance, so that no transaction is being missed and no transaction is processed twice. Okay, both things has to be taken care of, right? Now this appear a very simple stuff. The consumer is reading the data from a topic and then writing in a table. But there is a problem where reprocessing of same event might happen in this architecture. And how that is possible, let us try to understand that. Okay. So actually in the back end, it happens like this way. Our producer front-end system is there, which is publishing the events or transactions in our Kafka. So our Kafka cluster is having multiple brokers. Within that brokers, we might be having topics. Within topics, we might be having partitions. Okay. Now we are having a consumer group. Within that group, we are having multiple consumers. Out of that one consumer which got the partition assignment after consumer rebalancing, so that consumer is reading the data from this partition. Okay. So based on polling interval, it will poll and fetch a batch of events. And then what it will do, it will process all of them. If the amount is deposited, it will add that value in the table, or if the amount is withdrawn, it will subtract that value from the amount from database table, and then it will make a commit in the database, right? So the consumer will write and commit in database table. And once the message is processed successfully, the consumer will write that offset also in our underscore consumer underscore offset topic, which is managed by Kafka only, right? So that from the next offset value onwards, it will poll and get the next batch of transaction for processing, right? So that's how this particular architecture should work. But think like this way, suppose the consumer has got certain set of transactions, it updated the amounts based on deposit or withdrawn nature, it will update that in table, and it will commit that information. Now the database is updated, it is perfectly fine. Now due to some reason, after updating in this database table, if the consumer is not able to commit that offset, then what will happen? Then if the offset commit fails, when the consumer will poll next time, again the same set of messages which it already processed, that same set of messages will come again as part of response, and according to that the same processing will happen in the database side also. So basically this way reprocessing of same message is happening, which may lead to a very big problem in our financial system. And this is happening only for one reason, that these two are different operations, that is writing and committing the informations or processing whatever we have done in database, that is happening in one transaction, and then consumer is committing the offset. They are not happening in a same direction. They are two different operations. So it might happen that first operation is successful and the second operation is failing. That is perfectly possible scenario, right? And in that case we might have problem of reprocessing of same message. So we need to avoid this problem. So to avoid that problem, what we can do, that we will be opening a transaction in this particular table which is having all the account balance information. There the consumer will do all the operations based on amount is deposited or amount is withdrawn from the account, and in that same transaction only, in that same table, might be in a separate column, it will keep the information of offset, that is up to what offset it has processed. Okay, and then once that processing is done as well as offset is updated, it will commit that transaction. Okay, that way offset commit and the database processing both is happening in a single transaction. If suppose database processing is complete and when it is trying to update the offset value, if it is failing, then the whole process will be rolled back. Okay, that way when next time it will get the same set of messages, if it does that operation in the database table, then also it will happen only once, because earlier operations whatever it has done, that is rolled back, right? So what I mean to say, basically this kind of architecture, that will be having our producer, will be having our Kafka cluster, within that will be having our broker, topics, partitions, etc, etc. Consumer will consume from a particular partition, and then in that same account master table only, there will be a column which will track that offset value, that up to this offset the consumer has processed the informations. Okay, so suppose for example consumer has updated all the amount, but anywhere it is failing to update the offset, then the whole process will be rolled back, because it is happening in a single transaction, so rollback is possible. So both operations, that is whatever it has done operation due to deposit or withdrawn of amount as well as offset commit, both will be rolled back, and next time it will try to do that. Okay, so that way reprocessing will not happen if we follow this kind of architecture, right? I hope you can easily get it. That is consumer will commit the offset in the database itself. Okay, so suppose for example within our consumer group, whenever a new consumer is assigned a particular partition, then what will happen? From this particular database, that new consumer will take the offset up to which the processing is done, and from the next offset onwards it will start processing the messages from a particular partition. Okay, and suppose for any scenario if a consumer is leaving the consumer group, okay, or if the consumer is going down, in that case the consumer will commit that offset in this database only, and then it will go down. Okay, so all the operations, that is database related operations as well as offset commit, whenever new consumer is added or new consumer is shutting down, in both cases offset commit will happen in that database only. Okay, so we will not consider the offsets whatever will be written in Kafka __ consumer _ topic. Okay, so if you consider this particular architecture, which is basically for exactly once processing, suppose a new consumer is added. Now when it will make a poll request, first it will check whether it is an initial fetch or not for that consumer. If it is an initial fetch, then rebalancing is triggered, right? So maybe there are some other consumers which are consuming the data from a partition. Kafka will rebalance the operation, and might be different consumer will be assigned new partitions. And then in that case, we need to make sure that whenever rebalancing happens, then the consumer which got the assignment to consume the message from a particular partition, from where it will start the consumption of messages, that information, that offset value, it should go and fetch from database. That kind of modification we need to attach in the code, okay, to tell Kafka explicitly that don't take the offset value from __ consumer _ offset topic, but rather take from the database. Okay, That mechanism we need to add in this architecture whenever rebalancing happens, whether a consumer is added or whether a consumer is going down. In both case, in the database it need to update, right? So like for example, here another picture can give you some better idea. Suppose we are having a topic called topic A and we are having multiple partitions, partition 0, partition 1, partition 2, partition 3, etc. And as of now, within this particular consumer group, we are having 3 consumer. Consumer 1 is consuming the message from partition 0 and partition 3. Consumer 2 is consuming the message from partition 1 and consumer 3 is consuming the message from partition 2. Okay, here I have written the partitions also for which different consumers are assigned. Now suppose a new consumer C4 is added. Okay, now what will happen? Rebalancing will happen. Now if you see this consumer 1 consuming the message from 2 different partitions, so obviously from this consumer 1 partition will be revoked and then it will be assigned to this particular new consumer C4, right? So what operation should happen in the backend if we are introducing the offset commit in database? That first the partition will be revoked from this particular consumer, and up to what offset the consumer has processed for the partition 3, that first it need to commit in our database. Okay, once it is committed, now what will happen? That this consumer 1 will only consume from partition 0 as it was earlier doing. Now the partition 3 will be assigned to the consumer 4, and as soon as it is assigned, the consumer C4 need to go to the database table and it need to understand that particular offset value up to which the consumer 1 has already processed earlier, and from the next value onwards the C4 will start processing. Okay, that's how it should work. So in simple words, I mean to say, whenever rebalancing happens, 2 things happens in the backend. One is, first, 1 partition will be revoked from a consumer, and whenever it is revoked, up to what offset the consumer has already processed, that need to be updated in the database, and then when a new partition will be assigned to another consumer, that consumer need to know from which offset it need to consume the data. So on partition assignment, one activity has to happen, and on partition revoked, another activity has to happen. And all things is happening whenever rebalancing happening, right? That is whenever one consumer is spinning up or whenever one consumer is spinning down from our consumer group. So in that rebalancing case, how to know that when rebalancing is happening? And based on that, we want to trigger a particular piece of code which will help to do this activity. So that is the question now. How will we do that? That is, whenever a partition is assigned to our consumer, we need to make sure that we position the consumer at the latest committed offset before processing any record. And conversely, when an assignment is revoked, we need to commit the current offset to make sure that they are not lost. Okay, otherwise there is always possibility of reprocessing of same message, right? How these 2 things we can make sure? And that we can make sure using rebalance listener. Okay, so this can be implemented using rebalance listener, which is registered when we subscribe to a topic. Okay, what is rebalance listener? I will show you, no need to worry. So there is a code we can write, rebalance listener, which will run automatically whenever rebalancing happens within our consumer group. Okay, now let's go to that particular code. So before that, what I will do, I will start my zookeeper here with the common code, and I will start my Kafka server also. So if you see here, our zookeeper is started in default port 2181 basically. So if I just scroll up somewhere, you will see here it is running at port 2181, right? Now I will open a new terminal and I will start my Kafka server, which will run in default port 9092, right? So here you can see broker is running at default port 9092. Okay, now what I will do, I will create a Kafka topic having the name hello world. Okay, so here the topic got successfully created. Perfect. Now what we will do, I will show you the code. So here this is the very simple producer code which is publishing the message in the topic hello world, which just now we created. Okay, as of now I am not passing the key, so different values will be shared across different partitions in round robin fashion, right? That is perfectly fine, no problem, because just we are doing for POC. And let's go to our consumer code. So here we have imported all the necessary modules as we did earlier. Then here if you see, a new piece of class I have added which was not available earlier. Okay, so what is this? This class name is my consumer listener, right? And here it is basically inheriting from this particular class Kafka consumer rebalance listener. So this Kafka consumer rebalance listener class is available in our package itself. I can just do a control click and show you. So here you can see it is an interface. Okay, so if you see class consumer rebalance listener, there are two methods that whenever partition is revoked, then what activity should happen. So it is just a pass, that is, it is not doing anything as of now. We can implement the method in the child classes. So that's what we did in our consumer demo yt.py file. And similarly there is another definition on partition assigned. What is happening? So here in this interface it is just pass. What we did here in this particular class, this class is implementing that interface and getting inherited from that particular class only. And here when the partition is revoked, then here I am just printing that partition is revoked. Whenever partition is assigned, then I am printing the partition is assigned. That's all. Okay, but in our actual scenario what we need to do, that if we want to commit that offset in a database, because we seen that there is a problem in committing offset in consumer offset topic and writing the data in database, to avoid that we got the solution that we will commit that offset in database itself. Now to do that we need to perform some extra operation here. That is, whenever a particular partition is revoked, then for that particular partition up to what offset the messages are processed, that also we need to write in the database with an update query or insert query. And whenever a new partition is assigned, from where the consumer need to consume the data, okay, that also we need to add here. So I have not added that here, just I want to show you that whenever rebalancing happens, then automatically these codes will be triggered. Okay, that's the agenda why I have written this particular code. And then here I am creating my consumer. I have given my bootstrap-server, value deserializer. First I am doing string decoding and then I am converting that to dictionary, just reverse operation what we did in producer side. Because in producer side first we converted that JSON to string and then we encoded. So in consumer side first we are decoding and then string to JSON conversion we are doing. Here group ID we are giving, auto offset reset earliest we are giving, and enable auto commit false we are giving, because we will commit ourselves. We are not allowing Kafka to commit, right? Now here we are creating an object for our listener class, what we have implemented, and then here consumer.subscribe. So when you are subscribing to this topic, we are configuring that listener should be this. So if you check the documentation, you can easily understand that in the consumer.subscribe, there is a functionality of listener. Okay, if you see the explanation, that here you can include the listener callback, okay, which will be called before and after each rebalance operation, right? So the listener class will be called, methods will be called whenever any rebalancing happens. That's what is expected. And then here I am doing a simple operation, that is for message in consumer. I am just printing the messages, okay, and I am committing the offset, right? But as of now I am committing in consumer offset topic, but we can implement the same in the database offset level also. And same code I have written in another Python file which will act like another consumer. Okay, so let's see whether rebalancing code is triggered or not. So I will run my this producer code which is publishing messages, and now I will start my first consumer. Okay, so whenever this consumer is coming, this is first time in our consumer group something is coming, so first rebalancing will happen. Now as it is only one consumer within our group, so obviously it will get the responsibility of both the partitions. Okay, so in our Kafka topic we are having two partitions, right? So if you see here that partition, topic partition 0 and topic partition 1 is assigned, okay, right? So this consumer got the responsibility of both the partitions. Okay, before partition get assigned, first partition should be revoked if anything is assigned, right? Because first time we are launching any consumer, so no partition is basically revoked, right? And then it is perfectly consuming the messages from producer in real time. Okay, so this particular code, when the partitions are assigned, this is running by what? This is running by our this particular my consumer rebalance listener class. This is listening to rebalancing in the backend and running automatically, right? Now I will start my another consumer. So as of now, this only consumer is consuming messages from both the partition. Now when I will start my this particular consumer, this consumer will get responsibility of consumption of messages from any of the topic among partition 0 or partition 1, right? So what should happen? First, from this particular already running consumer, one partition will be revoked. Okay, as soon as partition will be revoked, what will happen? That here we might add that particular code which will commit that offset up to which for that particular partition which is revoked, for that particular partition up to what offset the messages are processed already, that we will update in our database. Okay, and then that particular partition might be getting assigned to this consumer. So this particular on partition assigned method will be called, and then it will go to the database. It will get that offset value from where it need to consume the messages for that particular partition, and then it will process the message from that level onwards. So let me just run the code and show you. So if you see our previous code here, which consumer was already running, here if you see that here two values it is printed. Okay, so see the first one here, this consumer was having two partitions, right? So first see both the partitions are revoked. Okay, now here once it is revoked, the on partition revoked definition was called. Okay, right, in the backend whenever rebalancing happened, and there we can configure that for both of these partition up to what offset the consumer has already processed, and then this partition assignment is getting triggered. Okay, so on partition assigned method will be called, and here you can see that partition 1 is assigned. So here we can write a select query from what offset in database it should start consuming the messages for partition 1 that it can consume. Okay, similarly in the consumer 2 side, if you see here that first time here it is joining, so here no partition is revoked, only partition will be assigned. So now this consumer got the responsibility of consumption of messages from partition 0, and this consumer is getting the responsibility of consumption of messages from partition 1. Okay, so the on partition revoked and on partition assigned code are automatically working in the backend. First, the assignments are revoked, the latest offset up to which messages are processed that will be updated in database, then partitions will be assigned, and then any of the consumer got whatever partitions as responsibility to consume the messages, it will go to database, it will understand from where it need to consume the messages, and from there it will start consumption. Okay, as simple as that. So this is how we can avoid reprocessing of same messages. That is what we will do. We will commit the offset in our database only where we are updating the amount, and whenever rebalancing is happen, that is one consumer is shutting down or one consumer is newly joined, they need to go to the database table and they need to fetch the offset or commit the offset, so that all the messages will be processed only once and none of the messages processing is getting missed. Okay, right? So I hope you understood the concept of rebalancing listener. Now if you want to implement this in completely database level, that how I explained that committing the offset or fetching the offset from database, then you can check the link given in the description box. There is a beautiful blog available, so you can go through the code base also and then implement the same in your project. So I hope this video gave you the idea of rebalance listener, because this code is automatically getting called whenever rebalancing happens, that is one consumer is joining or shutting down, right? So like for example, I can go to the run console, and for example if I am just stopping this particular consumer 2, here rebalancing will happen, and then this, okay, let me just make sure that consumer 2 is shut down. So here if you see that consumer 2 shut down, so obviously rebalancing will happen somewhere. See here, the first it got revoked, and then once partition assignment got revoked, it will update in database that up to this offset for this particular partition it has processed that, and then assignment is happening. Okay, both the partition it got assigned. Now the consumer 1 only will take the responsibility of consumption of messages for both the partition. So whether it is new consumer is getting added or one consumer is shutting down, anytime our rebalance listener will be getting called. Okay, so this is called rebalance listener, because whenever rebalancing happening, it is getting called, right? So this is all for this video, what I wanted to discuss. Hope you understood the concept. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.